Thank you for joining me in this video. Our topic for today is binomial theorem or binomial series. So, but before we do that, there is a question I gave in my last video, that is video 1.1. Video 1.11, okay? Video 1.11, okay? If you check my video in my YouTube channel, you will see video 1.11, okay? There is a question I gave that I never solved, okay? So, let us do this. Now you check it with the one you did yourself to see if you got it right. 16x cubed minus 250, okay? In that video 1.11, okay, we treated difference and sum of what cubes, okay? So we have something like this, okay? What can we, this constant here, can it be reduced to a base and be raised to a power for us to still have 250? Is it possible? I don't think so, okay? So let us not waste just time. There's a common factor in each of the term, okay? And the factor there is 2. When I factor out 2 cancels 16, I will have 8s cubed. 2 cancel minus 250, I will have minus 125. All right? Okay, I can now factorize the one inside the parenthesis. Okay, I have 2 bracket, reducing 8 to 2x all with power what? 3, because 2 with power 3 is 8, okay? Then minus 5 cubed. 5 with power 3 is what? 125. Then we can now what? Factorize. So we have 2. All right. By the formula, we have this, okay? 2x minus 5. Then remaining one becomes 2s squared. Then since the sign here is plus, the one here should be what? Minus. The combination is 5 and 2s should give me what? 10x. Plus the remaining one, 5 squared, which is 25, okay? So, so you can raise this 5 squared to 25, okay? These 2s all squared to 4s squared, okay, if you want, okay, but it doesn't really matter. So that is our answer. If you got this, then you clap for yourself. Now, let's clean this. So, in today's program, we begin with binomial series. All right. First of all, we have to, I believe I've treated what binomial expression means, okay? It means an expression that contains only 2 terms separated with plus or minus signs, okay? So in terms of binomial series or binomial theorem, it's a theorem that talks about the expression of a binomial or expression of the power of a binomial, okay? So I say that it's a theorem that talks about the expression of the power of a binomial, okay? And that power of that binomial must be a positive what? Integer. That is why we call it binomial theorem of what? Positive integer, okay? So it says that suppose we have the binomial of the form x plus y raised to power n, where n is a non-negative what? Integer. That is actually n is not less than 0, okay? N is not less than 0, okay? So it means that n is what? A positive what? Integer. All right? So we clean this now. So having had this binomial here, this n is the power of the binomial or index or the exponent of the binomial. The binomial here are what? The 2 terms here, x plus what? Y. Okay, so how do we actually expand this? How do we multiply out this power of the binomial? Mind you, binomial multiplication, we shall have s plus y into n times s plus y into n times. Okay? So because n is not known, so we don't really know where we will stop, okay? So But by the binomial formula, we shall have, let's clean this first. By the binomial formula, we shall have, this is equals to taking the first term of the binomial x with the power, original power of the binomial n, multiplying it by the second term y with the zeroth power, all over what? 0 factorial. Plus, that is how we establish the first term. So the first term is established by taking the first term of the binomial, which is x, raising it to the original power of the whole binomial, then multiplied by the second term, which is y. Then the power of y will start from what? 0. Then we divide by what? The 0 factorial, okay? So any power of y is what we have to divide by, okay? So for us to form the second term, all right, we shall multiply this n by 1 here. We have nx. Then we subtract 1 from n to have n raised to the power minus 1. That's x raised to the power n minus 1. Then y raised to the power 1 all over 1 factorial. Okay, so again, for us to have the third term, okay, we have plus, multiplying this n minus 1 from this second term here, okay, by n, we have n bracket n minus 1, you close your bracket, then x raised to the power n minus 2, okay, because n minus 1 is equal to what? N minus 2, all right? So, we clean this. All right. So, then times y raised to the power what? 2 all over 2 factorial. Like I said, you always divide, okay, by the power of what? Y. In the first term, we divided by what? 0, okay, because the power of y here is 0, so by 0 factorial. In the second one, the power of y here is 1, we divided by what? 1 factorial. The third one, the power of y is what? 2, we divided by what? 2 factorial. Okay. That, mind you, n is not really known, okay, so we can't stop. It is infinite, all right? So, let's do the last one. Then, for us to have the fourth term, okay, we multiply n minus 2 times n bracket n minus 1. For us to have, let us write it here, to have n bracket n minus 1, okay, multiply by n minus 2, all right, then x raised to the power n minus 3. When you subtract 1 from minus 2, okay, you shall have minus 3, okay, so n minus 3 then times y raised to the power 3 divided by what? 3 factorial, then till infinity. So that actually is the binomial formula. At this juncture, I will use number, okay. So let us clean. Please do not get confused by this abstract, okay? Now, suppose we have this question, 2x plus 1, okay? With the power 2. Now, let us multiply out, okay? Let us multiply out the binomial, or the power of the binomial, all right? Now, which shows that 2x plus 1 appears twice. So we shall now multiply, okay? Using this to multiply this, and again to multiply what? This. Again, use this to multiply this, and again to multiply what? This. So, from the first one, I have 2x bracket, 2x plus 1, and again, plus 1 bracket 2s plus 1. Now 2s times 2s, we have 4s squared. 2s times plus 1, we have plus 2x. Plus 1 times plus 2s, we have plus 2s. Plus 1 times 1, we have 1, okay? These are like terms. We sum to have 4s squared plus 4x plus 1. Like terms, we just sum the coefficients, okay? So this is the expanded form of this binomial here, okay? All right. So this is actually how we can multiply out without using the binomial formula. But actually, suppose the power of this binomial becomes 5, for instance, okay? You see that we will go through some rigor trying to find the binomial what? Coefficients. Okay, so at this juncture, we shall employ what we call the binomial formula, which I gave before using abstract. Let me clean to show us what I mean. Let's drop. Okay, now let us still leave the power of the binomial to what? Each second what? Degree. So by binomial formula, it is simple. Please, when I did the abstract, I knew it was confusing to you guys, but look at this thing as I do it with number. Now take the first term, which is 2x, raise it to the original power of the binomial, multiply it by the second term, which is 1 times 1, raise it to the 0th power, divided by what? 0 factorial, plus multiply the coefficient here, 1 by 2 to have what? By the power of the binomial, which is 2, to have 2 brackets, 2x, then subtract 1 from these 2, the power of the binomial to have what? 1, multiplying it by what? Y raised to power what? Power 1 all over what? 1 factorial. Again, use this power of binomial here, power of this term here, okay, 2x, so multiply 2, okay, to have 1 times 2 is still 2, multiplied by 2x raised to power what? 1 minus 1 is 0, multiplied by what? 1. 1 plus 1 is what? 2 all over 2 factorial. At this juncture, we are meant to know that 0 factorial is equal to 1 and also equal to what? 1 factorial. Anywhere you see 0 factorial or 1 factorial, you substitute 1, okay? And again, 1 raised to power 0 is equal to what? 1, which is equals to 2x raised to power what? 0. That is the law of what? Indices. Now, in standard form, we have 2x all raised to power 2 by indices will give me 4x squared, because 2x all raised to power 2 means that 2 is raised to power 2. 2 times 2 is what? 4, then x squared, right? 0 factorial is 1, okay, so no need, so I write that. We have 2 times 2x, okay, I have 4x, all right, 1 factorial is 1 also, okay, 4xy. Then, what else? I have 2 factorial is 2 times 2, which is 1. Sorry, 2 factorial is 2 times 1, which is 2. Okay, so therefore 2 factorial we cancel what? This 2 here. 2x which always power 0 is 1. So 1 squared is 1 times 1, which is also what? 1. So do you see? I have the expansion at this point. So this is how you can do this using binomial what? Formula. If you factorize this, you get back to this expression. Sorry, please, there is no y here. I thought there was a y. There's no y, please. It's 1. Okay, so if you factorize it, okay, using normal factoring method, okay, you will still have this perfect square binomial, okay, given here. So let us clean and give another instance. Okay, so suppose this question is a little bit complicated. Let us have it to minus 2x raised to power 2 minus 4y or raised to power 3. Okay, by binomial formula, we just have minus 2x squared raised to power 3. The first time we take the power of the original binomial, okay, multiplied by minus 4y raising to the power of what? 0, divided by what? 0 factorial, plus, okay, 3 times we have 3 brackets, minus 2x squared raised to power. When you subtract 1 from 3, you have 2, multiplied by minus 4y raised to power what? When you add 1 to 0, you have what? 1, divided by what? 1 factorial. Again, plus, you multiply 2 by 3 to have 6, multiplied by minus 2x raised to power 2, subtracting 2 from 1, sorry, subtracting 1 from 2 here, I have 1, times minus 4y raised to the power. Adding 1 to 1, I have what? 2. I divide it by what? 2 factorial. Plus 1 times 6 is still 6. Multiplied by minus 2x. Okay, squared. 1 minus 1 is 0. Multiplied by minus 4y raised to the power. 2 plus 1 is what? 3. Then we divide it by what? 3 factorial. Okay, now we are meant to know in our former example that 0 factorial is 1. 1 factorial is also what? 1. Now in this case, 2 factorial is equal to 2. That is 2 times 1. 3 factorial is equal to what? 6. Okay. So we know that minus 4y all raised to the power 0 is 1 by the law of indices. So this reduces to minus 2 x squared raised to the power 3. Then please be careful. Here is 1 factorial, which is also 1. Then I have 3 here. Okay, I have 4 here. This will be minus times plus is minus. So I have 3 times 4y times 2s squared all squared. Okay, then plus, again I come here, minus 4y all squared is 16y squared. Okay, but first of all, we shall divide 2 factorial, which is 2, by what? 6. That is 6 over 2 will give me 3. Okay, so I will have 3 times this. Okay, 3 times bracket minus 2s squared. Okay, times minus 4y all squared will give me 16y squared. All right, then plus the last one, 3 factorial is 6. That is 3 times 2 times 1 is 6. Okay, so 6, 3 factorial and 6 can cancel itself. So I will have and we are meant to know that minus 2s all squared raised to the power minus 2s squared raised to the power 0 minus 2s squared all raised to the power 0 is 1. Okay, so here I will be left with minus 4y all cube. Okay, which is now minus 4 cube y cube. All right. So let me clean for me to have some space. Okay. So here I will have my final answer. Now here minus 2s squared all cube will be minus 2 cube, which is minus 8. Okay, s 2 times 3 is what? 6. Okay, then minus for the second term I have minus. Okay, 3 times 4y gives me 12. Okay, 3 times 4y gives me 12, right? All right. Okay, so 2 times 4, 12. Then 2s squared all squared. 2 squared is 4. So 4 times 12 gives me 48. Okay, so I will have minus 48x raised to the power 4y. Okay, plus for the third term I have it is still minus. Yes. Okay, it is still minus, no more plus. Okay, because of this minus here in these two attached to 2. So 3 times minus 2 will give me minus 6 s squared. That is 3 times minus 2s squared gives me minus 6s squared. Then minus 6s squared times 16 will give me minus 2s squared. Sorry, 3 times minus 2 is minus 6. Minus 6 times 16 is minus 96. So I will have minus 96 s squared y squared. All right. So the final answer becomes still minus. Okay. minus 4 into 3 gives me 64. Okay, y cube. All right. So if I clean this, so I have the answer already. Okay, but I can actually put it in this form. That is by factoring out minus outside. Okay, to have minus times 8x raised to the power 6 minus, plus 48x raised to the power 4 y, okay, plus 96x squared y squared, then plus 64 y cube. Okay, so this is now my answer. Please, I want you to do this on your own. In my next video, I will still solve it, okay? So do this. Find the binomial expansion of 0.5x minus 2 all raised to the power 4. Please, using binomial formula, okay? All right, there are other formulae that I will still apply, combinatorics, Pascal's triangle, okay, in my other videos, okay? Hope you found this helpful. Please do subscribe to my channel. Thank you for watching.